Okay, so we're just going to try and punch through as many of these questions as we can. I'm going to be doing this on OneNote. I haven't really tried these questions before, so you might have to deal with some of my thinking noises. You can skip ahead to the questions that you want to do. Really, this is an up to you sort of situation. Okay, so first things first, we're just solving logs. For this first one, I can see that I can make this match with this. So it's going to change into being log with base 6 to the power of 6 to the power of 2. Now that they match, this equals 1 and I'm left with whatever the power is. So in this case, x is equal to 2. Let's see if we can get this pen a little bit finer. Okay, next one. First thing I'm going to do is move this log 3 over to this side. That's going to leave me with 4x minus 7 equals 3 to the power of 2. I'm just going to rub that out so it does look like a minus or whatever, take most of it. Okay, so now I can capture this one and move that to the other side by adding 7. This 3 to the power of 2 becomes 9, not 6. Okay, so now I've got 4x is equal to 9 plus 7. 4x is equal to 16, therefore x is equal to 4. Hopefully they'll give you more space in your exams. This question, if I look, it's already ripe to be solved using our null factor rule. So I'm going to solve this bracket first. Let both of them equal 0 and then rearrange to get x on its own. That will give me 2 is equal to ex. When I take e across, it will become natural log 2, or I could say it's log with base e, x. This one, 0 equals e to the power of x minus 3. So then 3 is equal to e to the power of x. Take this to the other side. Natural log 3 is equal to x. Now, if I scroll down, okay, so now I've got two logs with the same base, adding, which means we're going to multiply them. So log x, 2x minus x is equal to 0. Now I can take this across by making this one e to the power, because remember ln is equal to log with base e. So that's why that becomes e to the power there, and I've got 2x. I'm going to expand this in the same step. So 2x minus x squared is equal to 1. Anything to the power of 0 is always 1. Take this to that side. 0 is now equal to negative x squared plus 2x minus 1. And I can factor out the negative here, and change this symbol. That way, I've got a positive and I don't have to do the more difficult way of factorising here. Even though I've only been telling you that factorising is important for most of my natural life, but it's cool, whatever, it's cool, here we are now. Okay, so now I'm looking for two numbers that add to equal negative 2 and multiply to equal positive 1. So our factors must be negative 1 and 1. So then x minus 1, x minus 1, they're both equal to 0. So now I can use null factor rule. Because they're both the same, that means that I'm just going to be left with x is equal to 1. Okay, now we're looking at our derivative rules. Now, it's important to get familiar with the formula sheet because it will help you in these sorts of situations. So all I have to do is take the derivative of each part of these questions. So I'm going to do ex first. So when I take the derivative of, how am I going to write this? Like this, that's going to be equal to, so ex derives into ex still. We take the derivative of the top, so the derivative of x is 1, that will come down and multiply, which is why this stays the same. Plus, now I'm going to do the derivative of the second part. Sine goes to cos. If you remember that, you'll remember most of it. So that becomes cos 2x, and then it's the derivative of the inside of the bracket, multiply the front. So the derivative of 2x is 2, so that's how I end up with that answer. For this question here, we're going to take the derivative of sine x, that's going to come to the front, and multiply our function here. It's like an application of chain rule. So this will become cos x e to the power of sine x. Remember, the power above e never changes. So that's our derivative. This one here, this is the same as saying cos x to the power of 3. Now, anytime you see that, you know we're going to be using chain rule. So chain rule is just the derivative of the inside of the bracket. So cos will go to minus sine x, derivative of the inside multiplied by the derivative of the outside. Okay, and then I just fill my equation back in there. Beautiful. Okay, so now I've got minus 3 sine x cos x, and I'm just going to write it back the standard way that they like that. Okay, next one. Again, we're going to take the derivative of each section. So this first one is going to become 1. Now, when I take the derivative of this second part here, I'm going to do that calculation to the side. So I'm going to let u equal x and let v equal ln x. So v dash is equal to 1 over x. So the derivative of whatever in this bracket over the original function. So the derivative of that is 1 over the original is x. U dash is just going to be 1. So here, these two functions have a symbol in between them. Now, the reason why I'm using product rule is because I have two sets of x there. So I've got x times ln x, which is why we use product rule. So product rule is this one times that one plus this one times that one. So x times 1 over x plus 1 times ln x, which is going to leave me with 1 plus, this will cancel with that to leave me with 1, plus ln x, which is going to be 2 plus ln x. Okay, now I've got one where I've got a function with x on the top and one with x on the bottom, and they're dividing. So that's how I know it's going to be quotient rule. Okay, so I'm going to start by writing it to the side here. U always equals the top, v always equals the bottom. So now I've got u dash equals 2, v dash equals 2x plus 3. So I always remember this as it's this one times that one. Okay, so this one is v first, but the formula for that is given to you in the formula book. So v u dash minus u v dash. Well, my handwriting's going a little askew here. All right, so all I'm going to do is fill it in. So x squared plus 3x multiplied by 2 minus 2x plus 3 times 2x plus 3, and that's all going over x squared plus 3x squared. Now, when it says give to the simplest form, most of the time that means I'm expanding the top and I'm going to group my like terms. Sometimes they expand the bottom still, but only if they think that it's going to cancel out. In this case, I don't think it is, so I'm just going to leave the bottom like this. But just double check in the marks guide what they're asking for, because I could be different to what they're asking. Okay, so now I've got 2x squared on the numerator plus 6x minus 4x squared minus 6x minus another 6x will be minus 12x minus 9 when I expand all of those brackets fully. So normally I would do this multiplication first, and then I would multiply by my negative after. Because they're all positive terms in here, I've just changed them all to negative now. But otherwise, I would go through and make sure I did that in 2 steps, or that's where my error would show up later. Okay, so from there now I can group my like terms. So 2x squared minus 6x minus 9 all over x squared plus 3x plus 3x squared. Now, this is where I would normally be looking for a trick, because if I think that I could factorize this to be the same as the bottom, I can knock out one of the brackets. But I've already tried it on this one and you can't. So that's the trick to look out for in that in your external exams. Okay, now we're going to be doing some integration, definite integrals. Okay, so when I integrate that function, 4x squared, it's going to become x to the power of 3, which means now I'm dividing by 3, multiplying by that constant in the front. And now, if it's a definite integral, that means I sub 3 in first, get my answer, subtract 1 substituted in, get my answer. So, 4 times 3 cubed over 3 minus 4 times 1 cubed over 3. That's going to give me, now here, this 3 will knock out one of those. So it's 4 times 9 will give me 36 minus 4 over 3, which is like 1 1/3. So if I take 1 off the 36, that makes it 35, and then I take another third, which will make it 34 2/3. Now, the other thing I have to put here is units, or units squared, because this is area underneath the curve. Okay, now I can integrate the next one. Remember, when we integrate, you take the derivative of this and it's going to divide that function. So it'll become e to the power of 2t, derivative of this is 2, so divided by 2 multiplied by your constant, plus t has got a power of 1, so it'll increase to 2, so it'll be divided by 2 as well. So now that I'm doing my definite integrals, I can put my brackets and put my 2 and my 0 there. If it wasn't definite, I'd be putting the plus c on the end. Okay, so now I'm going to substitute these values in. So I'm going to simplify this one to just be 3. So 3 e to the power of 2 times 2 plus 2 squared over 2 bracket minus 3 times e to the power of 2 times 0 plus 0 to the power of 2 over that. So now that I've got this, I can start simplifying. That will become 0, that becomes 1, so the end of this is just minus 3. This here will become 4, 4 divided by 2 is 2. And the front of it is going to be left with like that. Okay, so now I can group my like terms here. I'm still going to be left with 3 e to the power of 4. The plus 2 minus 3 will become minus 1, and that should be my final answer. Okay, I'll finish the rest of it because we've got class.